Elementary Algebra, Final Assessment 4, Review, Questions 1 through 4, Outcome 1, Graphing. Question 1's instructions read, plot and label the points indicated by the coordinate pairs. In question 1, we're given two ordered pairs, point A and point B. Point A, we're given the ordered pair 6, 5. The 6 represents the point along the x-axis, and the 5 indicates where we'll move along the y-axis. The x-axis moves horizontal from left to right, and the y-axis moves up and down in the vertical. When plotting a point, we always start at the origin. This is the point where the x and the y-axes cross. It is also indicated as the 0, 0 point, or origin. Starting at the origin, we'll move either left or right as indicated by the number given. If it is in the positive, we'll move to the right. If it's negative, we'll move to the left. In this case, we're given for point A a positive 6. So we'll move out to the right 6 places. 1, 2, 3, 4, 5, 6. We now have the 5. The 5 is for the y-axis. If it is positive, we would move up. If it were negative, we'd move down. In this case, we're given a positive 5, so we'll move up 5 places. 1, 2, 3, 4, 5, and place our point. We can now label our point with our ordered pair, 6, 5. Whenever placing a point on a graph, be sure to label this point. The next one we're given is the B point, which is given as -1, 1. So our x will be a -1, our y will be a +1. Again, we come down to the origin, and we're going to move left or right as indicated by the x. In this case, our x is negative, a -1, so we move to the left 1 place. Our y in this one ends up being positive. Positives move up, so we'll move up 1 place as indicated by the y position and put our dot. Now we'll label it. It's a -1, 1. Now, typically, when labeling a point, you'll place the ordered pair, but on occasion those ordered pairs are given some other type of label to indicate them. In this case, our two pairs were given the letter E. Use the letters A. We can also use the letters given with these ordered pairs to graph or to label our points on our graph. So over here to the right, I'm going to use the same points, but I'm going to label them using the letters given. For the first one, I was given the letter A, so I'm going to follow the same procedure, come out 6 places and then up 5 for the Y. So 1, 2, 3, 4, 5, 6, then up 5, 1, 2, 3, 4, 5, and place my dot. But this time, instead of using the ordered pair to label, I'm going to use the letter A. Now I'm going to move over and place the B on here. I'm going to start at the origin again and move over a -1 as indicated in my ordered pair, and then up a +1 and place another dot and label it B. In question number 2, we're given the instructions, determine the slope and the y-intercept, then graph the equation. The equation we see here is given to us in a standard form. Standard form is ax plus by equals c. Before we can determine the slope and the y-intercept, we want to rewrite our equation to isolate the y. This means we want to place our equation into the y-intercept form, which is y equals mx plus b. So we'll take our given formula, 4x plus 5y equals 28, and start moving towards isolating the y. We start by moving the x out. We want to move the x to the other side, so we'll subtract the 4x off both sides. This will leave us with the 5y on the left side of the equal sign. With the 28 and the negative 4x, they're not alike, so we can't subtract them. But we want to make sure that the x goes into the front position because we want it to look like our y-intercept form. So we'll write this as minus 4x plus 28. Next, we want to move the 5. We'll move the 5 out by dividing it. It's multiplying the y currently, so we'll divide it out on the other side, making sure that it divides out through all the terms present. So this clears it on the left, leaving us with y equal to a negative 4/5 x plus 28 over 5. So now we have it in the slope-intercept form. This means that we can read the slope directly out of the equation as well as the y-intercept. These two items were asked for in the instructions. Our slope is our M position. In our M position, we are given a negative 4/5. So here is our slope. Our Y position, our B position is going to tell us our y-intercept. In this case, our B position is a 28 over 5. So our y-intercept will be 0, 28 over 5. This is like saying the 0, B position, the B position in our original slope-intercept form. So we've actually solved the first part of our instructions. It told us to determine the slope and the y-intercept. We have done so. The second part says then graph the equation. So we're going to come over here and we are going to graph the equation. Let's start by graphing the y-intercept. We look at our y-intercept. Dividing 5 into 28 leaves us with a 5 3/5. So we're going to start at the 0, and we're not going to move left or right because it says to stay at 0 on the y-intercept, but we are going to move up 5 3/8 of a place. So 1, 2, 3, 4, 5, and approximately 3/8. So our point's going to be approximately here on our graph. So we have a 0, 28 over 5. Next, we want to graph another point. So what we're going to do is use our slope in this case. We're going to use the rise over run. We have a negative 4 over 5. The negative 4 means that we will drop down 4 places. So our rise over run. So we'll start at our point and drop down 4 places. 1, 2, 3, 4. Now we're going to run 5 places. It's a positive number, so we'll go 5 to the right. 1, 2, 3, 4, 5, and we have our next point. Now we can place our graph or place our line. Now we've completed all parts of the instructions for question number 2. Question number 3's instructions say simply to graph. If we look at the problem, we're given y equals x to the second power minus 2. This is a quadratic equation. Quadratic equations in 2 variables will always graph as a parabola. We can graph this by simply finding points, by simply plugging in values and solving. Because the x is raised to the second power, we're going to pick on the x because it'll make the solving simpler. So I'm going to come in here and take y equals x to the second power minus 2, and for the first one I'm going to attempt plugging in 0 on my x and solving to find an ordered pair. I see that when I plug this in, y equals 0 to the second power minus 2 gives me y equal to a negative 2. So my ordered pair is 0, comma, -2. I could do this for a second point. I can come in here and try plugging a 2 in for my x. So I end up with y equals x to the second power minus 2, plugging in a 2 on my x, or x equal to 2, would give me y equals 2 to the second power minus 2. This solves as y equals 2 to the second power is 4 minus 2, so y is equal to 2. So my ordered pair is 2, comma, 2. Let's find one more point before we start graphing. I had a 2, comma, 2. When I look at these pairs, what I want to do is start creating my parabola. So if I kind of look at the 0, comma, -2, and I graph this on the paper, I see a 0, -2 is graphing down here as 0, -2. My other one graphs as 2, comma, 2. If I'm trying to create a parabola, I probably want to point somewhere over here on the left, so I'm going to look for a negative value now to kind of create this parabola. So I'll try plugging in x as being equal to a -2 for the opposite side. Y equals a -2 raised to the second power minus 2 would give me y equals a 4 minus a 2, which leaves me with y equals 2. So now I have an ordered pair that is a -2, comma, 2. So I come up here and I come out a -2 places and then rise 2 places. This now gives me a -2, comma, 2. And I can see that this is starting to create my parabola. I have met the requirements of the instructions. I have graphed this equation. Problem number 4 gives me the same set of instructions as number 3, just simply to graph. When I look here, the function of x equals a -x to the second power minus 2x minus 5. Again, this is a quadratic equation in 2 variables and will create a parabola. So I'll start in the same fashion I did before and choose values to plug in for x and solve. So I will start with y equals a -x to the second power minus 2x minus 5. Let's start with the simplest value for x, which would be 0. X equals 0. So we're going to come up with y equals a -0 to the second power minus a 2 times a 0 minus a 5. When we solve this down, this means that y equals a 0 minus a 0 minus a 5, or y equals -5. So my ordered pair on this one will be a 0, comma, -5. I'll come over here and graph that point. Because it's 0, I'm not going to move left or right, but it is a -5, so I will go down 5 places, 1, 2, 3, 4, 5, and place my point, and also put my label, 0, comma, -5. Let's pick another point. The next value I'm going to choose is 1, because 1 is a simple value, make for simple math. So I'll do the same. X equals a 1. Plug it in. So y equals a -1 raised to the second power minus 2 times 1 minus 5. This gives me y equals a -1 minus a 2 minus a 5, so that y is equal to a -8. So my ordered pair here is going to be a 1, comma, -8. Let's place this one on the graph. So I'll start at the origin. It's going to be 1 out and then come down 8 places. 1, 2, 3, 4, 5, 6, 7, 8. Put my label, 1, comma, -8. All right, I can kind of see a line just sort of coming off in this direction. So either I've got a parabola that's coming up and around to the right, or I have a parabola that's coming up and then back down to the left. Let's try to find a value on the left side and see if that helps us see where our parabola is going. Let's now try a -1 and see where it graphs. So I'm going to come in here and choose x equals a -1 and plug it in. So I end up with y is equal to a negative, comma, -1 to the second power minus a 2 times a -1 minus a 5. So then y is equal to a -1 plus 2 minus 5. So y is equal to a -4. So in this case, my ordered pair is -1, comma, -4. Let's graph this one. So I'll come to the origin, come out one place, and come down 4. 1, 2, 3, 4. I'll place my dot and label it a -1, comma, -4. I kind of see this thing is angling off towards the left side of the page. So I can see that my parabola is going to come off to the left. So let's pick some more values on the negative side, following this pattern. So this time let's try an x equals a -2. So we'll plug in, so y is equal to a negative times a -2 raised to the second power minus a 2 times a -2 minus a 5. So y is equal to a -4 plus 4 minus 5. Y then is equal to a -5. So my ordered pair is -2, comma, -5. Let's put this one on the graph. So we'll come out here 2 places, 1, 2, and come down 5 places. 1, 2, 3, 4, 5. I can see now that my line has actually turned to create my parabola. So I have a -2, comma, -5. And come in here and complete my line. It's making a turn here, and it's going to go down somewhere. So I've created my parabola. I've met the requirements of the instructions and graphed this quadratic equation.